Bars hibernate, solar activate, falcon, flask, and silver stripe, and typo 3 flow. Agave, Pixie, Hazar, MVC, code ignites a lithium, and PRADO. Raphael, Bobo, Bottle, and Tornado, Django, Cherry Pie, and WSGI, Class, Hammer, Web, Sphere, Red Beam, Turbo Gears, Albatross, Aquarium, Selenium, Web Pie.
We're gonna build a framework, 'cause we wanna use one, let's go wanna choose one. We're gonna build a framework, didn't like the others, so we'll rise another.
Sitecore, Tapestry, Maverick, and JSP, Barracuda, Akarama, Groovy on Grails, Intercal on Interstate, Cascade, and Hibernate, JDBC, Ruby on Rails, Jasmine, Doctrine, Java Forms, Engine, Active Record, D3, Dapper, and Velocity, Time Leaf, Top Link, Pyramid, Rethink, Aura, Rico, Midori, and Mojito.
We're gonna build a framework, 'cause we wanna use one, let's go wanna choose one. We're gonna build a framework, we didn't like the others, so we'll rise another.
Site Mesh, Cymbeline, Enterprise, Java Beans, Hook, Grok, Boost, Click, anything by Telerik, Rango, Dojo, LLBO, Gen Pro, Carbonado, Seaside, Pylons, and Peroxide. Fusebox, Flight Flex, Service Stack, Silex, Carbon, Coco, Amble, and Giotto, Banshee, Symphony, Laravel, Fat Free, Maca, Hobo, Cuba, and Rialto.
We're gonna build a framework, 'cause we wanna use one, let's go wanna choose one. We're gonna build a framework, we didn't like the others, so we'll rise another.
Open REST and Nancy, ASP.NET, MVC, Kendo, Zen, ODBC, and Tempo, Java Server Faces, Entity Spaces, Cappuccino, SpecFlow, Polymer, JDO, Google Web Toolkit, no need to learn JavaScript, JDK, code away, what else do I have to say?
We're gonna build a framework, 'cause we wanna use one, let's go wanna choose one. We're gonna build a framework, we didn't like the others, so we'll rise another.
Prototype, boilerplate, jQuery, animate, mustache, tempo, ionic, and Allegro, bootstrap, backbone, running on an iPhone, mobile app going live, built-in HTML5, Angular, Scriptaculous, React, Redux, Knockout, Ember, does anyone remember? Just like in the browser wars, I explore in Netscape for Lodash versus underscore, and I can't take it anymore.
We're gonna build a framework, 'cause we wanna use one, let's go wanna choose one. We're gonna build a framework, we didn't like the others, so we'll rise another. We're gonna build a framework, 'cause we wanna use one, let's go wanna choose one. We're gonna build a framework, we didn't like the others, so we'll rise another.
Good afternoon. Dobry dnia, DotNext. So, my name is Dylan Beattie. I'm going to be talking to you this afternoon about real-world REST and hands-on hypermedia. So, a little bit first about me. This is me. The best way, if you want to follow up with any questions after the conference, is to find me on Twitter. I'm over here. I have a vk.com page, but I have no friends there because I can't speak Russian, so I don't know what they're saying. I've been building websites for a long, long time. I built my first web pages back in 1992, when the World Wide Web was like 1 year old. I've been building web applications and data-driven websites and things ever since. I am the systems architect at a company called Spotlight in London, who do data-driven systems for actors, films, television, all these kinds of things. Really, really interesting industry to work in. And my website is here, which is where I write blog posts about software architecture and REST and all kinds of stuff. But we are not here today to talk about that. By the way, just let me mention all of the code, all of the slides, everything you're going to see today. It is already online here, github.com/DylanBeattie.next. The code samples I'll be showing are there, so you can download those and run them afterwards, try these things out for yourself. And ja nie говорю по-русски. I do not speak Russian, I speak English, and I sometimes speak English very fast. So if anybody would like me to repeat something, just give me a little wave or do this with your hand, and I'll just go back and I'll repeat, or we can take a question or something if things aren't clear. Okay? Okay. So the talk today is about REST. REST is a very well-known style. A lot of people have heard of it. A lot of people have worked with it. There is still a lot of confusion about what REST is and why it's important and how you can use it to solve problems. So today we're going to be looking at some of those solutions. But first of all, to get a sort of clear understanding on what RESTful systems are, we're going to go right back to the very beginning, to the source. This is Roy Fielding. Roy invented REST, and Roy basically decided what REST is. There's a lot of stuff in software and computing where there's argument about how things work and what different words mean to different people. REST has a very clear definition that we're going to go through in the first part of our talk today. Roy is now the senior principal scientist at Adobe. He worked on Apache. He's one of the founders of the Apache web server project. And he was one of the authors of HTTP, the actual underlying protocol that binds the web, the World Wide Web, together. And in 2000, Ray published this, Architectural Styles and the Design of Network-Based Software Architecture. This was his PhD thesis, his university thesis, in which he outlines an architectural style for creating scalable software across networks. That's the very first important thing to understand. REST is not a framework. REST is not a library. REST is not something you can install. REST is not something you can download. REST is a set of constraints, rules and restrictions and guidelines about how you should solve certain problems that you will encounter in your applications. Roy's thesis is it's very readable. It's well worth checking out if you're interested in taking all this right back to the beginning. There's a couple of sentences I want to highlight. He opens by saying this: when given a name, a coordinated set of architectural constraints becomes an architectural style. Now his thinking on this was actually influenced by architecture in the sense of buildings, in the sense of building churches and offices and houses. There's a lot of thinking in building architecture about patterns and about architectural styles. And a lot of that thinking, I was in St. Petersburg yesterday walking around, there are some amazing buildings here. Now, you look at the styles, the way that certain things are done, the domes on churches, the pillars on some of the palaces and big houses. It's not a blueprint, it's not a design, it's a style, it's a set of patterns. And REST is like that, like most software architecture. It's a set of patterns you can apply to your systems. Then he says what I think is the most important point to take away from this. REST is software design on a scale of decades. Every detail is intended to promote software longevity and independent evolution. REST is designed to build systems that are going to run for years, maybe decades. If you are going to run out of funding next month, you probably shouldn't be building a RESTful system because many of the constraints are directly opposed to short-term efficiency. You will often find you have a problem in a solution or a project you're working with, and there are two ways you can solve it. Well, lots of ways you can solve it. There'll be a way that is quick, and there will be a way that is RESTful. REST often takes more time. You have to think about lots of things that may not be immediate problems for you and your organization now. So be very, very conscious of this. Think about what it is you are trying to achieve. If you're working, lucky enough to be working on a system where you are planning something that is going to run for many, many years, There's a lot of ideas and patterns in here that hopefully you will find useful. If you are building a prototype, if you're building an MVP, if you're doing a little experiment to see if something will work, REST is not necessarily going to help. It won't necessarily hurt, but often you'll find some of this will slow you down. Okay, so Roy Fielding defines REST. He says REST is a coordinated set of architectural constraints. So what are those? First thing he says is that software systems should be built to run on a client and a server. I'm hoping this is not a surprise to anybody here. Most of us, I think, have built server-client applications. You know, websites, email systems, FTP systems. This is a very, very common pattern now. I don't need to explain very much, but you know, the rule of thumb here, your server is shared between lots and lots of people. It has your data storage. It's where you have behavior and security, the things that you want to manage centrally and enforce centrally. Your clients are where you handle some processing. One of the nice things about client server, every one of your customers brings a computer with them. So if you have calculations to be done, you can distribute those. The more customers you have, the more power you have to run your application. It handles presentation, it handles user interaction. The other big advantage of this, of course, is that server serves multiple clients. You can serve lots of, thousands of users with a single server if you design your systems properly. The second constraint he identifies is something called stateless. Now, has anyone here worked with ASP.NET or PHP or Cold Fusion or classic ASP or kind of written any website in the last 15 years? You'll come across this idea of session. You know, have you seen this where you have a session cookie? Session takes this idea and it breaks it, just cracks it, doesn't work anymore. If you've ever had a problem where you had something like ASP.NET and you were running one web server and it starts to get a bit slow, so you install another web server and then nothing works. It's because session is state. It means that when you are sending requests to the server is allocating some storage just for you. And it's like this is yours, we're going to hang on to this for you. And the next person comes along and they get some state just for them. And the next one. And what happens is your server gets full. And then one of the clients goes away. And you're like, well, we don't know if they're coming back. So we have to hang on to this storage for them. We have to remember this. You know, what's your session time at? 5 minutes, 10 minutes, 24 hours? It makes it very difficult to decide. But the biggest problem with this is if you provision another server to give you some more capacity, and then one of your clients gets bounced from this server to that server, when they get there, it's going to blow up because the state that they're relying on is in the wrong place. So by avoiding state, by building stateless systems, you have a lot of flexibility about how many clients you can cope with and how you can scale across multiple systems. The third constraint that Roy identifies is cacheability. Basically, this is the premise. You have a resource on a server, the client requests it, resource comes back. If the client needs it again, it shouldn't have to make another round trip. It should be able to just use the one that it's already got. There are two numbers to think of in terms of caching. Anytime you do anything on your server, you do a calculation, maybe you render some video, you render a photograph, anything that costs resources, can you reuse it? Because the best things to do, you can cache never or you can cache for infinity. If you've done something that might ever be used again, see if there's a way you can keep it forever so that anyone who ever comes back and requests that same resource again, you can just give them one you've already got. The next constraint, which is very tightly tied into that idea of caching, is the idea of layered systems. My favorite example of this is the idea of putting a proxy between clients and servers. So clients here are, let's say, all of our mobile phones, iPhone, Samsung, Android, whatever we've got. Proxy in the middle, this thing is run by, who's the big telecom company here in Russia? Do you have Vodafone here, or is that just the rest of the world? So, big cell phone company, and they run mobile data networks. So they have a proxy where they store things, and then server is yours. You pay for this, somebody else pays for this, lots of people have these. So request comes in, you do some calculation. It costs electricity, it costs your company money. The phone company save a copy of the resource. If you've set it up properly, the next time somebody wants it, they get the proxy copy. You don't spend any money to fulfill that request. Now this pattern works incredibly well because it allows other people to pay to make your software faster without you having to do anything. And I think that's quite a neat idea. The other thing that you can do with the idea of a layered system is you can put in more layers. So layered system means client and server don't care what they're talking to. So in this example, the client's talking to a proxy. The proxy thinks it's talking to the server. The proxy is actually talking to a security appliance, talking to a firewall. The security appliance thinks it's talking to the server. It's actually talking to a load balancer. The load balancer thinks it's talking to a server. It's actually talking to 5 servers. So we can spin up new ones. We can shut down old ones. None of them cares. You know, if we put a load balancer into a system, you don't need to tell your clients, your web browsers, your customers that you have a load balancer. You just put it in, and everything works. It gives you an awful lot of flexibility in scaling your applications. Uniform interface. Before HTTP and REST came along, if you wanted some information on a server, there were, I don't know, a couple of dozen protocols. There was Gopher, there was FTP, there was Telnet. There were all of these different systems that all had a different way of interacting with remote information and remote services. One of the things that HTTP and REST does is it says, okay, let's standardize this. First of all, identification of resources. URLs, you know. It seems funny to think somebody invented the URL, but they did. They had this idea, here's a protocol part, HTTP, here is a host, here's a port, here's a path, here's a resource. Anything on the internet that is available via network requests can be identified using one of these URIs. Manipulation through representations is the idea you can ask for something in different formats. If you want a piece of data as JSON, you can get it as a representation. If you want it as CSV, Excel spreadsheet, plain text, JPEG, these are all representations of some underlying resource, some piece of information. Self-descriptive messages, you should be able to look at the things that are happening on the network and make sense of what it is they're trying to do. In HTTP, we have get, we have put, we have post, we have delete. They're descriptive. You know, get is an English word. It means get me something. Put means put this over there. Delete means remove that. So that allows you to look at network traffic in a sort of diagnostic or debugging tool and make a lot of sense of what's actually happening with it. And finally, something he called Hypermedia as the engine of application state, which is what we're going to be talking about for a good chunk of the talk today. The last constraint that Roy identified is the idea of code on demand. Your server should be able to send resources which include code. The client can retrieve them, disconnect from the server, and then run them later. I've never actually seen an API that does this. I've seen lots of web applications that do this, you know, Google Docs Offline and Gmail and lots of single-page applications. And I'm also not mad keen on the idea of getting like execution code from someone else's API and then running it on my system. But it's nice to know that the capability is there, because what this allows you to do is to run operations on your clients that they weren't designed to take care of. You know, when they've built the first web browsers, they weren't supposed to be email systems. And then someone went, well, they run JavaScript. So we can write an email system in JavaScript and send it to the client, and they can run it there. So the important thing about all of this is that Roy Fielding explicitly says these are 6 constraints, and only this one is optional. So if you're building a system and you have these problems, if you solve them that way, your system is a RESTful system. If you solve them another way, it's not. That doesn't mean it's good or bad. It doesn't say anything about the quality of the system. But if we're going to talk about, you know, companies say, oh, we've got a REST API, I think it's really important that we can agree on what a REST API is, because it has a definition. The guy who invented it said, this is what it is. And if it doesn't do this, it's not REST. It might be brilliant, but it's not a RESTful system. Okay, so those are the constraints. Let's see what they're actually going to look like in real life. Well, not in real life, in comic book life. Because what we're going to do is we're going to build a system, we're going to write some code, and we're going to build a social network for comic book superheroes. Because it's going to be fun. You know, heroes are big. There's all sorts of, you know, the Marvel movies and DC movies. There's big money here. There's all these really interesting characters. And we don't want to get bogged down in doing user interface development. We don't want to be testing JavaScript. So we're just going to build an API and let everyone else come and plug their own code into our system and do whatever they need to do. So this is the entry point. Get/HTTP, and it's going to give back, hey, welcome to HeroBook. Then we're going to create 2 endpoints. We're going to create an endpoint here called /profiles. Well, we're going to create one endpoint which has 2 methods, get/ /profiles, you go there, it'll give you back a JavaScript array, a JSON array of all of the people who've joined our network. We're not worrying about security because this is a 1-hour talk and there's a lot of stuff we could go into. So, and then we're going to expose this. So if you post to /profiles and you give it a JSON payload, you'll get a 201 created, and it'll say, your new profile we've created for you is over here, and here is a copy of the data that you got back from it. Yeah? And then we're going to put some documentation online so that everyone knows how to use our system, and we're going to go home for the weekend. And when we come back on Monday, it's gone viral. Someone put it on Reddit, and someone put it on Twitter, and it got retweeted by, I don't know, Donald Trump or somebody. And we've got 2 million users have signed up. And we're sitting there looking at the system going, wow, that's a lot of stuff. And then the phone rings. And we pick the phone up, and the person on the end says, Vaš API zabil ves náš kanál. Which, now I don't speak Russian, but I think that means your APIs used all of our bandwidth. And the phone rings again, and I say, Vaš idiotský API перегружает нашу базу данных. Which I think means your stupid API has overloaded our database. So what's the problem here? Why has this happened? Why are our network engineers upset with us? Yes? We're responding with 2 million records. We've only got one endpoint. It's /profiles. The only thing is you can do with it a get and post. And if you do get, you are going to get 2 million records every time. So every time anyone tries to use our API, they're getting megabytes and megabytes of data, and the network can't cope. The database can't cope. The whole system doesn't scale. So what can we do about it? We could do this. We could say, all right, let's take our endpoint and break it down. So we're going to say, OK, get profiles, page equals 1. And then we can go, OK, so let's get page 2, 200, OK. Let's get page 3, 200, OK. 200, OK. 204, no content. Yeah? That's fine. It looks pretty simple. This would work. I'm sure most of us here could go and build a system that did this. And when we get to no content, it means that's it. You've got all the profiles off the system. Now go and do whatever you need to do. That is not RESTful. And the reason it is not RESTful is that it is not using Hypermedia as the engine of application state. When we get that first page, there are places we can go from there. We can go to page 1, 2, 3. But there is nothing in the response that tells us that any of that's possible. So, what are we going to do about it? Now, does anyone ever remember these? Did any of you have these when you were a kid? These were choose-your-own-adventure game books. This was like way before we had even 8-bit computers. You'd get these at the library, you'd open page 1, and it would give you like a little chapter of a story, and then at the end of the page, it would give you a choice. Say, you want to do this? Well, let me give you an example. So I've built a special one just for us here. So this is the .NEXT St. Petersburg hands-on Hypermedia choose-your-own-adventure. So we've had an awesome first day at .NEXT in St. Petersburg. We're at the conference after party. Now we got to decide what to do. It's been a busy day. Could go back to our room and get some sleep. Some people are going out to have sushi, or we could stay at the party and watch Eugene do his Slim Shady karaoke. Yeah? So this is content here. This is a payload. And then embedded in that resource representation, we have some Hypermedia operations. To go to our room and sleep, turn to page 23. To go out and eat some sushi, turn to page 41. To stay at the party and watch a karaoke, go to page 52. So let's quick show of hands. Who's going to go to sleep? Okay, so we got a couple of people. Who's going out for sushi? And who's staying for Slim Shady karaoke? Yeah. Did anyone see that last night, by the way? It was really, really good. So there we go. This is Hypermedia. This is a resource which contains in it some Hypermedia annotation that describe how we can interact with that system. So now let's see what that actually looks like in code. So We're going to be using, for a couple of these demos, a format called HAL. HAL is basically JSON with extra bits. It's a superset of the JSON language. It stands for Hypermedia Application Language. The reason I'm using it is because it's quite short, so it's easy to fit the data on the PowerPoint slides. There are lots of formats, and it takes a long time to go through them all. But basically what we're going to do is, instead of just returning this array, we are going to create a collection called items. We're going to return our payload, our content, inside that array. And we're going to decorate the resource by adding this links collection here. And that links collection is going to contain some URIs, some hrefs, links to other places we can go. These are state transitions that are available here, and Hypermedia is the engine that is driving them. And because it makes it much easier to build systems that use this, we're going to put in count is how many you got here, index is the page that you're on, total is how many things are there in the collection. So, let's have a look at some code. So, first of all, you're going to see some weird-looking symbols here. This is not some weird esoteric language. It's all C#, but I'm using a font called Fira Code. And what Fira Code does is when you type this, it shows you this. When you type this, it shows you this. So don't freak out when you see what look like funny little runes and mathematical characters. I love this font. I think it's brilliant. It's open source. You can download it here. I'm also going to be using a tool that I've created for working with these kinds of things. This is in the GitHub repository that I link to. There's another link at the end. Basically, this is an API Explorer tool that will run inside a web browser. At the one extreme, you have web browsers. They're very good at browsing pages and websites and buying things from Amazon and eBay. They're not very good at working with APIs. At the other end, we've got tools like curl, the command line HTTP thing, or there's specialist tools like Postman. They're very good for doing one request, but when you actually want to navigate a hypermedia system, not so much. So this kind of sits somewhere between the two. It runs in a browser, it's all powered by JavaScript, and it understands HAL, and it understands some of these hypermedia concepts. So we're going to go into our API, and we're going to hit /profiles, and hit go. So it's come back, we've just got that, it's come back with a 200 success, and there are 2 million records. Big thanks to whoever on the internet took every single comic book superhero and put it all on the internet in a big spreadsheet, because I just copied and pasted that for the demo. So whoever they are, thank you. So let's have a look at the code that makes this happen. So the first demo I've got here, this is ASP.NET Web API. You're all familiar with C#. I figured .next, most people are sort of familiar with .NET, IIS, ASP.NET. So this is just Web API, nothing terribly weird or esoteric. The code that does it is profiles controller, which inherits the API controller. We have a database, which is a demo database, and then we have this public object get, db database.listProfiles, return it. That's it. That's all it does. So how can we now start adapting this code to conform to those hypermedia conventions, break it down into pages, and link from one page to the next? So first thing that we need to do is we need to wrap our array up in something. We can't just return the array raw. Now, one of the things that I find really useful for this is in Web API and in .NET, you can create anonymous types, and then you can serialize them straight to JSON and get out almost exactly what you put in. Now, I think this is a really, really powerful pattern. Anonymous types will do a lot of strange stuff if you try and share them between .NET code modules. But if you're just doing it in a website, turning it straight to JSON, serializing it, and then throwing it away, what it means is that you can sculpt these little objects to look exactly like what you want your JSON to do, and then return them, discard them, and what comes out the other side now is there you go. So we've still got a 2 billion or 2 million things in an array, but now the array is inside a JavaScript JSON object, which means we've got a place where we can go and inject more behavior. So first thing we want to do is to cut it down from 10 million. So we'll go back into our code. We'll spin up a constant that says results per page on this is going to be 10. And then we've got a database that understands link and iQueryable, and it gives us a sort of query provider interface. So when we say listProfiles.take results per page, When that gets down to the database, it's just going to pick 10 and give us those 10. Okay? Go back over here, hit refresh, and instead of 2 billion, if you watch the scroll bar over there, yeah. So we fixed the network problem. Now when people go get/profiles, it's not going to crash our internet connection anymore. What do we need to do now? Yeah. So, next thing that we want to do is expose the ability to request a page. So we know we're on page 0. At the moment, our API isn't smart enough to get page 1, page 2, page 3. So we're going to put a parameter on the query string, index equals 0. We're going to go in here, and we're going to say, OK, so list profiles, skip that many, and then take 10 off the end. And when we go in and now run that, so still works. And because we know what happened, we can go and we can put an index on the query, and we can page through the result set. Is this on the right track? Is it RESTful? Not yet. And the reason it's not yet is because we need to know that you can do this. The code doesn't tell us that. We still need to go and read the manual or ask someone for help or put a question on Stack Overflow or something. So let's go back over to the code and add something. So we've got this result, which is an anonymous type, so we can throw anything we like into it. And we're going to go in here and we're going to say, OK, so result now has a thing called links. The underscore here is part of HAL. HAL says anything with an underscore is special and has special meanings. And then within that, we're going to put a next object. We're going to give it an href. And we're going to use C#6 string interpolation, which I always forget and then have to come back and put the dollar on the beginning. So when we get our result now, we'll have an items collection, and we'll have this new links object attached to it. So let's jump back over to our API Explorer, have a look at what happens. OK. So now we've taken our first steps towards having a proper hypermedia support in our API. We've got the idea that you've got a page 0 and you can navigate forwards. Now, there's still some problems with it. One, there is more than one thing available, because as well as going forwards, we can go backwards. 2, we know that we can jump to the beginning of the collection, the end of the collection. The API doesn't support this yet. Also, we're going to get to the end of the list, and this thing is still going to say next, next, next. And it's going to come back with empty arrays, and we're going to keep on clicking. So what we need to do to make this fully compliant is we actually need to do a little bit of logic to calculate where can we go from here. Now, this is the kind of thing I use little helper classes for. So this is a static object, a static method that returns a dynamic object. And what this does, we're going to give it the URL, the path. We're going to give it the index of the current page, the count of items on each page, and the total. And it's going to do some calculations. So it'll give us first and final. First is always going to be 0. Final is always going to be the maximum index into this collection. And then we've got a check here that says, well, if index is greater than 0, we can go backwards. But we can't go back past the beginning. And if the index plus the count is less than the maximum, we can go forwards, but we shouldn't be able to go past the end. And it returns links. Now again, it's dynamic. We can throw anything we like into this class, take it out of here, return it in the other thing. Because we're not crossing any .NET process boundaries and expecting the type model to survive on the other side, this is fine. All we're doing is we're spinning it up, we're turning it into JSON, and then we're throwing it away. So we come back in here, and instead of links being new all of this, we're going to say, hit the database to get a count of the number of things in the collection, total. And then we're going to say links equals hal.paginate profiles index count or page size and the total. And then when we go and run this, okay. So there it is. We've got first, final, last, next. We click backwards and forwards. You can now navigate this API, see the operations that are available. You'll see there, when we get to the first page, the next link disappears. When we get to the final page, the next link disappears. So it's the same data. We've taken that big 2 million records, we've broken it down into this sort of succinct, manageable representation, and then we've used Hypermedia so that anybody who accesses one of those resources can see in the response, okay, there are places I can go from here. There's things that I can do. So, right. End of part one. Let's move on. Social networks are about updates. It's about people sharing with their friends. They make friends with people, send friendship requests, and then they post an update saying, hey, look what I did this morning. Look where I am. Look what I did. So we've got Iron Man. Tony Stark is on our network, and he has a collection of friends. Iron Man, Spider-Man, Black Widow, and he has updates, status updates. And his first update is, hey, I'm building a new Iron Man suit, and I'm going to put a selfie stick on it, because selfies are awesome. Oh, yeah. And then he posts an update saying, oh, the selfie stick broke off. Oh, well, back to the drawing board, back to my lab. But of course, his friends, all of these are also profiles. So each of these updates has a set of friends, and each of those friends has their own updates. But the friends can also have friends. So all the friends have got updates and friends, and the friends' friends can also have updates. Now, here we're getting into something we call big data, because the big data is too much JSON to fit on one PowerPoint slide. That's my definition. Okay, so again, one, how do we fix this? We got a good idea. But first of all, there's a phone call. Wasz API zabił nasz опять. And wasz idiotski API перегружает нашу базу данных опять. Я говорил, нам нужно было дождаться PHP. Because, yeah, you never ever had performance problems in PHP, right? So how do we fix it? You know, what are we going to do now to solve this problem we've got? We're going to break it down. So instead of we just go get profile/Ironman and it brings back the entire connected graph of every single record in our social network, we're going to go and we're going to say, okay, so it links. We've seen already the idea of using links to go backwards and forwards. Now we're going to expand on it. We're going to say, okay, so self is a convention in systems that always points back to the thing you're looking at. Because you might have got there by a different route. You might have got there like from a link on a friendship, or maybe a search result, or a bookmark or something. So as you move things around on your URL, on your API, self can say, by the way, the thing you're looking at, if you need it again, this is where you should go and look. If you're building client-side caching systems, self will give you the key you can use in your cache to know whether a resource is the same thing that you got from somewhere else or not. And we've got friends, and we've got photos, and we've got updates. So we've broken this down. And now you go, get profiles Ironman, okay. Get profiles Ironman friends, okay. Get profiles Ironman updates. Get Ironman photos. Get Ironman photos. Oh, 1, 2, 3, 4. That looks like an interesting photo. Let's get that one. Oh, look, someone's made comments on it. They've left comments on that photograph. Oh, look, there's photo 1, 3, 4, 5, and someone's left comments on that. And there's 1, 4, 5, 6, and someone's left comments on that. And then phone rings. Я должен сделать 50 вызовов API просто, чтобы видеть одну веб-страницу. Yeah? Why do I need to make 50 calls just to draw one web page? And then the network engineer rings you again. Наш веб-сервер упали из-за того, что IIS-логи заполнили C-drive. У нас не года до таких проблем с PHP. By the way, how many of you have had this exact problem where your web server goes down and it's because IIS is just logging and filling up? Yeah. That's the most common reason I've ever had web servers fail, ever in my whole career. So what do we do about it? So we've taken this big resource that was causing problems, and we've broken it down, and now the little resources are causing problems. Now, there's a pattern here. If you remember one thing from this talk that you're going to go away and type into Google later, It's this magic phrase, resource expansion. Because what resource expansion allows us to do, if you're familiar with the idea of something like an ORM, where you can do eager loading, you can say, get me this object and include that one and that one and that one. Resource expansion is that for Hypermedia APIs. So we can go, hey, get me profiles Iron Man and expand his updates. So this is the reference, the link to that resource. And now we're going to include another thing here, which is called underscore embedded. And in embedded, we have a thing called updates. So we can say, get me that resource and expand these associated resources in line when you come back with it. So again, we're going to do a code demo, show you how to implement that. Now, one of the things that I want people to get from this talk, the stuff I'm showing you is not web API stuff. It's just stuff that works in C# if you have a web server. So for the second demo, we're actually going to use a different server. We're going to use Nancy. Anyone familiar with Nancy framework? Yeah. So we're going to use Nancy for the second part. So again, we've got we're on nancy.herobook.local now. We're going to go to profiles Iron Man. And we're going to get back this very, very simple JSON resource representation. And the code that makes this happen is this Nancy module here. So we've got a profiles module in our application. For those of you who've not worked with it, Nancy has this cool feature, or it used to until version 2, where they've had to change it because of async support, where it has a dictionary for each of the HTTP verbs. So get, put, post, delete, dictionaries, and you put the root in here. That's a dynamic argument object, which will be everything that got matched on the root template. And then that's the method you should call. So we've got a root here, profiles, and then the squirrely brackets username. What did I just do? Oh, cool. That goes to get profiles, and then the get profile method here takes the username, goes db.loadProfile, and returns it. Now, what we want to do to add Hypermedia is to add this links collection to it. But we can't, because db.loadProfile is giving us back an enterprise business entity object that's probably written by an enterprise business entity database architect. And if we phone them up and go, hey, can we put underscore links on your object? They're going to say, you can't do that. Underscore violates our naming convention. You're going to need to get permission from head office. We don't want to have to change our database to cope with HAL, because we might change our mind about it wanting to be called links. So what we want is a way of getting these strongly typed, enterprise type objects out, and then kind of changing them a bit so we can play around, we can do things with them. Now, this is the coolest chunk of code I ever got off Stack Overflow. It's a method called toDynamic. Just jump back a step. Hang on, I've lost a slide there. There it is. So it's an extension method built in C#. It takes an object. So you can take any object in C# and you say this.toDynamic. And then it uses reflection. It spins up an expando object, which is the underlying type of dynamics in C#. But it coerces that into being a dictionary of strings and objects. Then we use reflection to say, get all of the properties of the object we passed in. And for each one of those properties, I want you to go into the dictionary and add property name and value to it, and then turn it back into an expando object and return it as dynamic. So what this lets us do, take anything we got out of the database, called toDynamic on it, and bang, now it's wide open because it's dynamic. We can go in and we can bolt any extra classes, properties, methods we want onto that, and it will get resolved at runtime. So we can go in and we can put self, we can put photos, we can put updates. And again, because literally, at the top of this class, we're in strongly typed C# enterprise software development. We come out the other end, we're turning it into JSON and throwing it away. So this is a very, very good place to translate from those two kind of different paradigms of how you model software systems. So there we go. Self, friends, bolted on, jump across to the Explorer, hit go, run the code again. So that's step one. We've now created these Hypermedia navigation points from the code we're looking at. And you can see that Iron Man's best friend is some guy called Hanselman, who, I don't remember him from my comic books. Do you know who this guy is? But what we haven't implemented is expansion. Now, there's a point when you're building RESTful systems where suddenly you run out of specification because there's a good idea, there's a convention, but there is no kind of official body saying how this should be done. There's no RFC for resource expansion. There's lots of different approaches, but it's the pattern that's important, not the actual code. So all we're going to do in our example here is we're going to do the simplest thing that can possibly work. I'm going to jump in, and we're going to grab the query string that came in with the request. And again, because we're in Nancy, everything is dynamic until you coerce it to be something else. So now what we're going to do, we're going to type that into a string. Strings are nullable, so that's safe. We're not going to get anything blowing up. And then we're going to say, OK, well, if the expand string is not null and it contains the word friends, and then profile is dynamic, remember, so we can just go and bolt more stuff onto it. So we can say profile.embedded equals anything we like. Let's spin up an anonymous object with a thing in it called friends. And then we've got a getFriends method on our API that we already wrote. Why don't we just call that inline and put the result of that over here? And now when we jump back over to our Explorer, so there's the resource with no expansion. And when we put expand equals friends on it, it's going to do that database call, that API call in line, expand the result for us, and put it inside the embedded collection. And there you go. It's very easy with this kind of stuff to think that you need to write a whole lot of enterprise-based classes and .NET, C#, Nancy, HAL, parser, and all sorts of things for it. The point I'm trying to get across here, you don't have to do lots of that stuff. JSON or JavaScript is a dynamic language. JSON is a dynamically typed data structure. And C# can do dynamics, and it will translate them into JSON really quite happily for you. So you can do an awful lot of stuff. It's flexible. These changes aren't going to cause conflicts with your data access code. They're not going to break anything that happens on the wire, because all of that stuff is completely dynamic anyway. So this gives you a really flexible way of working with these hypermedia JSON formats. OK, so let's move on. There's one more thing I want to show you this afternoon. So we're now going to go get profiles Iron Man. We've got friends, we've got photos, we've got updates. But we need to make some money. And to make money, we need to sell our customers' data to big evil corporations, because that's how social networks make money. And we can't do that at the moment because we don't have any data that advertisers want. So we're going to add it. We're going to say, OK, how tall are you? How much do you weigh? We're going to sell you diet programs. Where are you? Where do you live? What's your location right now? What are you doing? What's your status? Where are you from? What's your hometown? What's your email address? Do you have a website? Tell us what your website is. And we're going to put a last modified date so that we have some idea of who's actually an active, fresh user on our system and who's not. So we put all this code live. And then phone rings. It's one of our application developers. And they say, I'm trying to do an update here. And I put in Tony Stark's new status, and it's failed. Now, we know it's failed because Tony Stark is flying in his Iron Man suit, and he's got his Apple Watch linked into it with the GPS. So his latitude and longitude are being updated all the time. So by the time you've tapped out the status, the resource is out of date. And you can tell what's coming. Почему мне приходится зазовить the put vs profile лишь для того, чтобы обновить координаты? And then мой обновление происходит с ошибкой 409 конфликт. Помогите. Help. That's right, I am done massacring the fine Russian language now. Yeah, so we got one person, saying, why do I need to put the entire profile in order to change one thing? And someone else is saying, every time I try and do an update, I get this 409 conflict come back. Why does that, what's going on here? Now, I mentioned in an earlier bit that there comes a point when you're implementing this stuff where you start running out of specifications. There's a couple of different ways we can approach this problem. One of them is we could have a rule that says if you do a put, but it only contains one field, then don't delete everything else. Just take the one field and just update that. Now this kind of works, but the problem with this is it's very easy for, if we wanted to wipe out all the other data, say in this example, because Iron Man's just got paranoid about being stalked on social networking, there's no way of telling the difference between this put and a put that says please remove all the other fields. And you can do things like set them to null or empty strings or stuff. But this kind of violates the pattern, it violates the convention. There's another thing, by the way, a lot of these operations you'll see 204 no content, which is just the server saying, I've done what you asked for, but really I have nothing to give back to you. There's no response, there's no answer to the thing you asked me to do. Another thing we can do is we can say, well, why don't we make the status an endpoint on its own? So we've just got this status, which is really simple. It's just a string. If you get the status, you get that string. If you put the status, you give us a string, we upload it. Again, this will work. Problem with this is you end up with massive APIs with really, really simple methods. Lots and lots of endpoints, which means you need lots and lots of hypermedia to explain to people that all those endpoints are available. There's an HTTP verb called patch, which is very cool, very powerful, and very, very badly documented. It exists. It says if you want to change some object on a server, you can send us a patch request. And you say, OK, this is brilliant. How do I send you my changes? And the documentation here, the RFC 5789, just says, oh, will you just send us a description of your changes? And you're like, what sort of description? How do I do this? It's up to you. You know, this is what the specification has run out here. You've run out of runway, you're on your own. So you can come up with your own conventions for how you are going to do patch, and they are all completely 100% standards compliant. So one way of doing it is, OK, so we're on our Linux workstation. We're going to download the file. We're going to run it through the diff command to make a patch file. And then we're just going to upload the raw patch file. We're going to use this custom content type here. So we're going to say application X means this isn't standard. This is something weird we're doing. But our server understands these, and our client understands these. So we can download JSON. We can edit it in Vim. We can do a diff on the before and after, send the delta. That's supported by this API. Bang, 200, OK. There are some libraries out there which give you a much better degree of control. There's a thing called a JSON patch. And what JSON patch allows you to do is to describe a set of operations to be applied to some resource. It uses a query syntax a little bit like XPath. So we could upload a resource that says, OK, profiles Iron Man. We would like you to, first of all, replace the status with this. And then Iron Man's just been on some big mission, and the Incredible Hulk was like totally saved his life. He's like, I want to make the Hulk my best friend. So we're going to do a move operation. We're going to find this resource here, and we are going to move it to this path here. So there we've got two different indexing syntaxes. One says find this friend by name, and the other one says move them to the top of the list. They're my best friend now. And there are libraries out there. There's a Dan Brewer has written one for Nancy, which allows you to do JSON patch and that kind of thing. And there's some quite interesting ways of describing them. But the last thing we're going to look at today is our very own variation on how to do HTTP patch, which is totally standards compliant. So we're going to patch conferences.next. We're going to use a custom media type, which is the epic selfie PNG. Standards compliant, remember, all we're doing is describing the changes. We're going to take this picture. We're going to describe the changes. And we're going to send it to the server. And the server is going to send back 202 accepted. Now, I think it should be 202 challenge accepted, because I think .next is pretty awesome already. And that is real-world REST and hands-on hypermedia. Spasibo. So we have a little bit of time left over for questions. So either questions now or...
Yeah, у нас еще есть 10 минут на вопросы. Давайте, у кого есть, поднимайте руки, я подойду.
Hi, thanks for the talk. I got two small questions. The first one about your example with Next and Pref
yes.
links. What if if you want your customer to specify the size of the page, or he want to specify the time of the day when he want to exchange rate, if we allow him to modify the link, would it be REST or not?
It would be REST if you included in the representation how they did it. So REST is a huge topic. What we've got today is just under an hour of kind of what it is and how you apply it. There's a thing called the Richardson maturity model, which basically level 0 is HTTP, but it's just XML. Nothing happens. You're using get and post for everything. Level 1 is kind of what we've talked about a little bit today. Level 2 is where you start exposing actions, like the ability to update a profile. And then the level 3, which is the highest model, actually describes all of the parameters and the types that these methods can accept. So what we could do is say expose /profiles, and then inside the links thing, we could have a next and previous, but we could also have a method in there called search, and we could specify that search will take a page size, which has to be a number, and maybe some query string if you want to be able to search by username, potentially something like a sort order if you want them in forwards or reverse alphabetical. And so you can extend it as far as you like. If you extend it with things that you have to look up in the manual, you're not RESTful anymore. It might still be a fine system, but there's nothing in REST that says it has to work this way. All it says is whatever it is that your system makes available, make it available using hypermedia that's in the responses from your API instead of writing a manual or a help file or something for it. Does that answer the question? Cool.
Second, very small question, not directly to REST, but I would ask you to share experience with dynamic types. Do you really use it in production? So how do you communicate the protocol to your consumers of your API, or I don't know, Swagger or tools?
So the question is, do we do this in production? And if so, how do we communicate the endpoints? So the customers we have, or the clients we have, partners using it in production right now, what we've done is to give them that API Explorer tool and the credentials they need and say, start here, and you can actually go and explore the API yourself. Because that way, the nice thing about that, one, there is some documentation accompanying it, which defines things like, there are certain lists and reference values and those kinds of things. But by and large, we try not to do that because, one, if you're writing documentation, you're not solving problems, you're describing the solutions. And two, documentation goes out of date. You change the system and you forget that there's an HTML page you need to update as well. And the nice thing about this, particularly when you have something like that Explorer tool, is the API itself is its own browsable documentation. And combined with something like, if you have a staging server or a test server, like a sandbox system, if you open the firewall so that your customers can get to that, you say, here, you can come in here and play around with anything you like. You can do gets, you can do deletes. We'll reset the system every night and put fresh data in it, so don't worry about breaking anything. And the developers I've spoken to, they would far rather do that than read a manual, because you can actually test the API calls. You can go, okay, if I get this endpoint, what's going to happen? So the API Explorer there, that's a real tool that I took out of one of our production code bases. The Nancy API there is something we're running, something very similar in production right now. And there's, like I said, a little bit of documentation that goes with it. But basically, we just share the endpoint and the Explorer and say, this is what our API can do. And that way, if you've built something awesome that your customers can't find, it's because you forgot to put the hypermedia references in.
Thanks.
Okay. Yes, another question there.
Hello, thank you for the great talk. Maybe you mentioned this and I missed, but I'd like to ask, how do you handle, how do you synchronize changes? You mentioned about some header if matched with something like a version, but maybe I missed this part.
So you're talking about how do you detect changes? How do you detect that a conflict is happening?
Yeah, and how do you resolve it on the server?
So one approach here is something we sort of talked about there. The smaller your updates, the less likely they are to conflict with something. Now, there's a couple of headers in the HTTP specification, the really useful ones here. You can send, when you send a request, you can send a if modified since, which is a date time stamp. And that tells the server, I have a copy of this resource from yesterday. If it hasn't changed, send me back 304 not modified. And so the client doesn't have to get the full resource. And you can use this with post and patch and put and all these other methods. So you download a resource, you make some changes to it, you send it back to the server, and you say, if modified since yesterday, accept this update because I'm working from the same baseline as you, so you can apply the changes. If the server has a different update, like you have a resource and say you've modified it and I've modified it, your modification will overwrite the resource with a new stamp. And so the server can then say, I can't accept that because you're working from out-of-date information. So here's a fresh copy. Please make your changes again and push them back. And there's also another header which is used for basically like checksums, MD5 signatures or some sort of validation sum. On the server, it's called e-tag. So when you get a resource back, it'll have an e-tag in the HTTP headers, which basically says, this is the checksum for this version of this resource. And when the client sends a request, it comes with an if none match, which basically says, I've got a version of this with this MD5 header. Please check this against yours before you apply the changes.
Okay. In the terms of implementation, do you store this data into the database?
In which bit of the system?
In terms of implementation of storing, for example, was modified since last modified.
Yeah.
Do you store this field in database?
It can go in a database. It can be, if you're working with resources that are persisted to a file system, you can use the modification date on the files themselves. It's up to you, deciding, particularly when you have like a resource with a sub-resource and associations, you need to decide what last modified actually means in your system, in your business. But once you've decided it, store it in a database, store it in something like a Redis cache, store it on a file system. There's lots of different ways you can do it.
Okay, thank you.
No problem.
Oh, thank you. And you were using the whole links with text and so on to link to, for example, friends of character. But is it the better way in terms of REST API to use the whole links instead of just IDs of friends and so on?
To use links instead of...
So you could just point, for example, Superman as friend of Iron Man, but not profiles/Superman. Is it a better way in terms of IP?
So you can, but the nice thing about using links, so if you have an ID, then the person on the other end, they need to understand what that ID can do. If you use a link, if you use an actual URI, then the client can always, it can effectively take the URI and it can do a GET request. It can say, I just got this thing in my response. I don't actually know what that is, but it looks like a URI. Let's fetch it and see what's embedded in there. There's a, can't remember who, I was reading a post yesterday where they're talking about the Amazon API for managing S3 buckets. And I don't know if any of you have worked with this, but the AWS, Amazon Web Services, S3 bucket is cloud storage. It's full of things. The buckets have IDs. When you do a request, it gives you back an ID. Now, the buckets themselves are on the web. They have URLs. And if the URL came back in the API, you could just copy and paste it and see what's in the bucket. But as it is, you need to know how to translate that ID back into a web address or into a resource identifier, which introduces another unnecessary hop. So one of the kind of patterns that makes these things work nicely is the idea that if a resource is online, it has a uniform or universal resource identifier, and that's the ID. Your database IDs are for you. Don't share them with the rest of the world, because you might change them. You might decide that actually you need to change because you've just got your 2.4 billionth record and you need to switch from using int32 to int64 on your primary key. So there's lots of reasons why you might need to change things. Remember, we're talking here about a software that's going to run for decades. So by using web addresses, at that point you're like, okay, well, if we've got URIs as our identifiers and links as our identifiers, we probably shouldn't be breaking those anyway because people might be relying on them.
Okay, thank you.
Just one more point to follow on from that, which is the sort of structure of the data we looked at, where you've got profile, and then profile has a thing in it called friends. The words there, friends, updates, photos, the names of those links, they form the vocabulary of your API. That's effectively your structure. And you can change the links as long as you don't change the names, because the client can then go, okay, I just tried to get something from a cached URL and it's not there anymore. Let me go back to the beginning. Now I know that I have to start at the root, and then from the root, I find this link or the link with this name, and then I find the link with this name, and that'll get me the resource I want. And that's what gives you flexibility. You can even take a whole chunk of your API and stick it on a different server. And because the links allow the client to do that hop, the client won't need changing. It doesn't need to know.
Thank you.
No problem.